Okay, so on to question is saying caffeine is the stimulant in coffee and tea. On has the molecular formula. So I'm going to write down the molecular formula of caffeine. It is C8H10 N4O2. Calculate the mass percentage of each element in the substance. Give the answers to 3 significant figures. So first, to answer this question, we will assume 1 mole of caffeine. So if we assume 1 mole of caffeine, we can find out how many moles of each atom there are in caffeine. Atoms there is. So for example, let's just do an example of how we would find the moles of carbon in 1 mole of caffeine. So if we look at our chemical equation, you'll see that there are 8 moles of carbon for every 1 mole of caffeine. So this gives us 8 moles of carbon. And if we multiply by the atomic mass of carbon, which is 12.01 grams per mole, so this value can just be found on your periodic table. Our moles will cancel out, and we're left with how many grams of carbon in 1 mole of caffeine. So 96.08 grams of carbon. So now if we were to do the same thing for hydrogen, I'm just going to skip and say that there are 10 moles of hydrogen. If we were to multiply it by hydrogen's atomic mass, which is 1.01 grams per mole, we end up getting 10.1 grams of hydrogen. Now for nitrogen, we have 4 moles of nitrogen. Multiply it by nitrogen's atomic mass, which is 14.01 grams per mole. And we end up getting 56.04 grams of nitrogen. And lastly, there are 2 moles of oxygen for every 1 mole of caffeine. Oxygen's atomic mass is 16 grams per mole. Multiplying these gives us 32 grams of oxygen. So if we were to add all of these masses up, we end up getting a total mass for caffeine. So total caffeine mass. So 96.08 plus 10.1 plus 56.04 plus 32 gives us 194.22 grams. Okay, so now that we have the total mass of caffeine, we can now find the mass percentage of each of the elements. So the mass percentage is equal to the mass of the component divided by the total mass multiplied by 100. Okay, so for example, let's start off with carbon. Mass percent of carbon is equal to 96.08 grams divided by the 194.22 grams, which is the total mass of caffeine. All of that multiplied by 100% gives us 49.47%. So that's how much carbon is in caffeine in terms of mass. For the mass percent of hydrogen, let's do the same thing. We have 10.1 grams of hydrogen divided by 194.22 grams times 100 gives us 5.20 mass percent of hydrogen. For nitrogen, we have 56.04 grams divided by the total mass times 100 gives us 28.85%. And lastly, the mass percent of oxygen is equal to 32 grams divided by 194.22 grams times 100 gives us 16.48%. Okay, so these are all of the mass percentages of each element. And if we were to add all of these values up, you know you did it correctly if it all nicely adds up to 100%. Okay, so let's see what the junior tutor said. The mass percentage of an element is the ratio of the mass of the element with the molar mass of the element expressed in percentage. Step 1 is to find the molar mass of caffeine. Okay, so they just pretty much, yep, so that's like the same thing as finding 1 mole of caffeine. They showed how the total mass would be around 194. And then step 2, find the mass percentage of each element. Yep, so they have 8 times the molar mass of carbon. So they pretty much just condensed all the steps. Yep, so this solution is correct. They got 49.48. The values are slightly different than mine because they used less significant figures for their atomic masses. So like instead of 14.01, they just rounded it to 14. But they pretty much got the same values, 28.86, 16.51. The solution is correct by assuming there is 1 mole of caffeine we can find the masses of carbon, hydrogen, nitrogen, oxygen, then calculate their mass percentages.